This is Algebra 2. If we can cut that part of it out, that'd be great. The whole popping the gum thing, super annoying to me anyway. This is Algebra 2, Review 1 through 40, Part 2. So we're going to kind of keep going through here. We're going to take a look at question number 2. Now, it's really similar to question number 1, but when we're talking about solving a system of equations by substitution, the first thing that you have to do is you have to get the equation, at least one of them, to solve for one variable. So whether or not you do that with the first equation or the second equation, it doesn't really matter, but you have to get one of those equations into either an x equals or a y equals format. I would probably pick the second equation and solve for just x. Does that make sense? Okay, so this one's a little bit more involved than number 1. So what's the first thing I could do to that second equation to get x by itself? Add 4y. So that's going to give you negative x equals positive 4y plus 33. I need to do one more thing to get x by itself. Because what's in front of x right now? A negative 1. So what do? Divide by the negative. Okay? So you wind up with x equals negative 4y minus 33. It ends up just changing the sign of everything that's over there. Okay? Does that make sense? Okay? Now that I have that, x equals negative 4y minus 33. Negative 4y minus 33 equals x. Those two things are interchangeable. Okay? So now what I can do is I can't plug that back into itself. That wouldn't make any sense. I have to plug that in here. So what does that look like whenever I go to substitute that in? Negative 3, parentheses. Okay, negative 4y minus 33. Okay, plus 4y equals 3. Perfect. Exactly right. Now, what's the next step after that? Distribute what? Distribute negative 3 to inside the parentheses, so just here. Okay, and the negative 33. Okay, so what do I get first? 12y plus 99. Okay, that takes care of that. So plus 4y equals 3. Okay, what's next? Great. Combine like terms, which is 12y and 4y, which comes out to be what? 16y plus 99 equals 3. Okay? I'm really happy to see a bunch of you with writing pens working things out. Okay, what's next? Okay, subtract 99 from both sides. Okay, that's going to give me 16y equals what? Negative 56. 3 minus 99 is negative 56. Negative 96. Okay, now what? Divide by 16. And I get y equals negative 6. Okay, negative 6. Okay, so that gets me my y. Now at this point, what do I do with that? Plug it in. Does it matter which equation I plug it into? No. So, but I still like that second equation because it's nice and simple. So I can do negative x minus 4 times negative 6 equals 33. Okay, negative x, what's negative 4 times negative 6? Positive 24 equals 33. What do I do with the 24? Subtract from both sides. Okay, so I got negative x equals 33 minus 24, which is what, 7? 9? Sorry, 9. Okay, so what does x equal? Negative 9, because I'm going to divide by the negative, therefore making the 9 negative. And so I should get negative 9, negative 6. Does that make sense? Now, there's a lot of other ways to solve a system of linear equations. The reason that I solved it this way is because it said solve via substitution. When it comes time for the test, you can use whatever method that you know or are most comfortable with in solving that. Does that make sense? Okay, but when it comes to the review, I'm going to work it out the way the question asks. All right, any questions here if we got all that work? Okay. All right, next up is 29. Okay, again, it's another solve the system. Granted, you know, we've kind of come down quite a ways through the list to get to number 29. It is interesting that it's the kind of the same type of question. So what can we be fairly sure that we're going to see on the test? Probably solving a system of linear equations. Okay? Does this tell me how to solve it? No. We can solve through substitution rather easily because it's one of those equations is already set up as 6x minus 27 equals y. I could go ahead and plug that in. Okay? Do we want to do that or do you want to try something else? Do that? Okay? It kind of lends itself for that. So how do I set that up, Macy? Five minus 4x. Okay, very good. Exactly right. Thank you. All right, what's next? Bree, can you tell me what I would do next? Distribute the, okay, to both terms? Okay. All right, what's negative 5 times 6x? Negative 30x. Okay. Negative 5 times negative 27. Is that going to be positive or negative? Positive. Good. Okay. I don't know what it is off the top of my head. What is it? 135. Okay. Equals 5 minus 4x. Okay. Jarrett, what would you do next? Add 4x. Okay, so we can do that. And what are you adding it to on the left side? Negative 30x, right? Okay, so what's negative 30 plus 4? Negative 26x plus 135 equals 5. Okay. Jacob, what would you do next? Okay, subtract 135 from both sides. Okay, good. Okay, so negative 26x equals what? Good. Okay, what would you do after that, Jacob? Okay, divide by negative 26 on both sides. Okay, what does that leave you with for an x value? 5. Okay, so x equals 5. Okay, Bobby, now that we know that x equals 5, what do you want to do? How are we going to get y? Okay, where do I want to plug it in at? Do you have any recommendations? Like what's that? Second one? Okay, good, because it's already got set up for y equals, so I got y equals what? Okay. Okay, keep going for me. What do I do next? Okay, and then finish that off and y equals 3. Okay, so I got 5 and 3. Do we feel a little bit more comfortable with some of these? Okay, they may not be the most missed questions for this class. And honestly, if I were you, I would probably even write down this list that I have over on the whiteboard, the 13, 5, 7, 16, 25, 14, 1, 3, 8, 15, so far 2 and 29. At least that way when I go back and watch the videos, I know what order questions are going to get answered in, right? So I can kind of fast forward, okay, I can see he's working on number 7. I need to see number 16. I can fast forward to that. Does that make sense? No? Okay. Number 6. There's not really, so what happens when making these is a lot of times I'll take a multiple choice test and you can choose to eliminate multiple choice options, except sometimes those multiple choice options are written into the test. So in this question, it says identify the graph. So originally there would have been multiple graphs for you to select from, correct? Now, hopefully with most of us, we know how to plug this in our graphing calculator, correct? You guys know how to do that? Is there anybody in here who does not know how to plug this information here and here into a graphing calculator? So everybody knows how to do that. Did anybody not do that needs to see what that graph is going to look like? All right, so let me show you. If I pull up a graphing calculator here, this is going to help you kind of determine if you see a question like this. So it says identify the graph of 1/5 x squared. It says the parent function is x squared. So let me show you what x squared looks like. And when it says parent function, what it means is the absolute, like most standard form of that type of equation. So whenever I hit graph, right, it has the most middle of the road curve to it. It's going up. Everything else is derived as being wider or narrower than that, or having a vertex that's shifted from that position. So this is the standard position of this equation. Does that make sense? So when we go and we look at the other equation, right, it's 1 divided by 5x squared. Okay, nothing else. It's not going to be, I can tell you based upon looking at it, that it's not going to be the vertex, right, where that trough is, that coordinate, is going to stay at 0, 0. And 1/5, that's positive. So is it going to open up or down? It's going to open up because the a is positive. And that, by a, I mean the coefficient to x is positive. And I can tell you that it's going to be wider than the parent function because it's a fraction. Okay? If it's a fraction less than 1, it's going to be wider. In fact, the smaller the fraction, the wider the graph is going to get. Okay? So it's going to be wider than the parent function. Okay, so let's take a look and see what that graph looks like. And so we should see something like this. Does that make sense? All right. So I think that kind of takes care of number 6. All right. Let's see, what's next? 26? Okay. It just simply says graph 8x plus 2y is less than -4. What do I have to do before I can graph it? Solve for y, except that, okay, so solve for y. So we're trying to put it in a slope-intercept form. Great, okay. So Raven, what's the first step in getting that into slope-intercept form? Subtract 8x to move it to the other side. So I've got 2y is less than -8x minus 4. Do you agree with that? Okay, great. Let's see. Somebody else haven't called me. Keck. What do I do after that? Divide by 2. So I'll divide by 2 here. How much do I divide the other side by? Everything. Okay, everything gets divided by 2. So y, does anything happen to the inequality symbol? Does it change? Does it flip? Why not? Because I'm not dividing by negative. Okay? All right, what is -8x divided by 2? -4x, and what's -4 divided by 2? -2. All right, so now I have to graph this. Okay? So if I was to write a graph, let's say it looks something like this. I got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Something along those lines. What's the first thing I graph in a situation like this? -2 on the where? On the y-axis. Okay, I heard somebody say x-axis. Okay, no, it's the y-intercept. All right, what am I doing from there, though? Down 4 over 1. So down 1, 2, 3, 4 over 1. Okay, I don't have any more room to go that direction, so what's my other option? Go up how much? Okay, go up 4 and back 1. Okay, so 1, 2, 3, 4, back 1, something like this. Is this going, the line that I would use to connect those points, is it solid or dotted? It's solid? It's dotted. How do you know it's dotted? Because it's not equal to. So we're going to leave this. And my line's not great because my graph isn't great. Okay, but now I have to figure out which side of it do I shade. Do I shade to the right or do I shade to the left? The left. Okay, somebody said to the left. Okay, how do you know? Y is less than. Okay, so I guess the question is that I should always be asking, is 0, 0 included? Is 0, 0 in, all right, is it on the left or the right? It's on the right, okay? So you said we should shade the left, correct? All right, so if I said 0 is less than -2, is that a true statement? No, so 0, 0 is not included. So it should be to the left. Okay, so something that I can always do is find something in the shaded region, or find a statement that's true. Which side of it does it fit on? Okay, so this should be approximately my graph and my inequality. Does that make sense? Okay. Andrea, how much of this is stuff that you're familiar with? About half of it. Okay. Okay, so let's see. We're going to double back to, or not double back to, 31. I thought I was doing 3. Okay. Now, do you guys know how to check something like that last question in your graphing calculator? No? Some of you do. So the final equation that we had was what? Y is less than -4x minus 2, correct? Let's say I wanted to check that, not to get my answer, but just to make sure that I did the right stuff, okay? So this is how I would do this. Okay, so I'm going to go into my y equals. Let's clear everything else out. I'm going to come up here, and I know I want y to be less than. So I'm going to come over here to the left. I'm going to hit enter until I get a shaded region that's on the lower part. Does that look right to you guys? Okay. So then I'm going to come over here with my arrow over here, and I'm going to get -4x minus 2 and hit graph. Okay? So does that confirm our answer? Yeah. And that's what I like to have. I want to be able to confirm my answer because sometimes I make silly mistakes, and I just want to be able to go back and check. Okay? But if the calculator disagrees with me, that doesn't mean that I just picked the answer that the graphing calculator says. It also means I need to go back in and fix my work, okay? Because the only thing that Mr. Wilcox is going to see, he's not going to see my graphing calculator when he goes to grade my test. He's only going to see my work. So if my work doesn't match my answer, what's he going to put on my test? Big fat DSA, right? Doesn't support answer, okay? So make sure that if you change your answer because your graphing calculator doesn't agree with you, that you also fix your work, okay? All right. Let's see, what are we ready for? 31? Okay. 31, write an equation in slope-intercept form for the line that passes through 5, 2, 7, 9. Okay. 5, 2, 7, 9. We want the equation in slope-intercept form. There are a couple of things that we have to do. Okay? We need a slope. Okay? And then once we have that slope, we need to use the secondary equation to get our slope-intercept form. How do I get the slope out of this? y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. That's exactly right. What is the y2? 9. Okay. What is the y1? 2. What's the x2? What's the x1? 5. Okay. 9 minus 2 is 7 minus 5 is 2. So we have a slope now of 7/2. Okay. Is that reducible? You could probably, I mean, we're not looking for a mixed number when we talk about slopes. Okay. So improper fraction is what we want. Okay. The next equation we want to use, does anybody know what it is? No. We want to get it into y equals mx plus b. Okay. Y minus y1 equals m. Okay. So identify the parts that are going to go in here. Do we know what's going to go in for y yet? No. Okay, what about y1? Okay, what do you want to use for y1? You want to use 2. Okay. Okay, fine. What about m? Okay, 7 over 2. Anything for x? No? Okay. What about x1? 5. Okay, so we're going to substitute those values in. So I got y minus 2 equals 7/2 x minus 5. Now what? Jarrett, what do you do now? Okay, distribute 7 over 2 to x and negative 5. Okay, so I got y minus 2 equals 7/2 x. Okay, 7/2 times negative 2. What's 7 times negative 5? Sorry, I don't know if I said something weird there or not. So what's 7 times negative 5? Negative 35. Negative 35 divided by 2. Does that evenly just go in? Okay, so it's just negative 35 over 2. Okay, now what? Add 2. But the problem is that that's a whole number and this is a fraction. Can I rewrite 2 as a fraction over 2 so that I can combine those? What is 2 as a fraction over 2? No. What's 2 times 2? Is 4/2 the same as 2? Yes. Okay, so I get y equals 7/2 x. What? What's negative 35/2 plus 4/2? Negative 31/2. Now, the answer key might have that as a decimal, and that's fine. That's what it is as a fraction. Okay. Number 9. Okay. Write the matrix equation for the system and solve. All the matrix systems are going to look the same in a multiple choice scenario. They're not going to change up the matrices at all. So I can go ahead and tell you that what you want to have is your left-hand side. So, 4, 3, 7, 5 times an unknown x and y value equal the solution 2 over negative 6. But that's not how we work it out, is it? No. Okay, how do we work this out? We do an RREF with a 2 by 3 matrix of 4, 3, 2, 7, 5, negative 6. Yeah. Right, and then we get an answer of what, 1, 0, 0, 1 with an answer for x and y here. Negative 28 and 38. Okay, with these being my answer for x and y. Okay, does anybody need to see that done in a graphing calculator? Okay. All right, so pay attention. You got a graphing calculator on you? Okay, go ahead and grab one if you don't have one. All right. So are you ready? Okay, so first thing we're going to do is hit second matrix. We're going to go to the right all the way to edit. Okay, and the first thing we need are the dimensions. So what are the dimensions of my matrix here? 2 by 3, good. Now we're just going to plug them in across. So 4, 3, 2, 7, 5, -6. And it's always wise to kind of take a look back through and make sure you got all your negatives, that you didn't accidentally hit a wrong button or something like that, because it won't tell you that you did anything wrong. So 4, 3, 2, 7, 5, -6, all looks good. So we're going to hit second mode to get out of that and come back in. So second matrix, we want to go to math, and we want to go all the way down from there to B, R, R, E, F. Then hit second matrix again and select that matrix that we made and hit enter. And so the right numbers in the column are -28 and 38. Those are my answers for X and Y. Okay? So we are familiar with that? We're well practiced with it? Okay. Okay, what's next? 9, 18. That's the last one I have on my list. And Yanalise, I haven't called on you in a while, so you help me out here. Okay, solve the system of equations using, we don't have to use inverse matrices. How do you want to solve number 18? How did you solve it? You got it wrong. Okay. We can solve this doing a matrix if you want to do. Do you want to try that? Okay. So I'm going to set it up. We're going to do an RREF. Okay. So second matrix. Now, can you help me and tell me what to do in here? Okay, so the first thing we're going to do is we're going to edit. Okay. Now, do you know what the dimensions of the matrix we want to make are? Okay. See how it has 2 rows and 3 columns. Okay, so we want a 2 by 3. Good. So 2 enter, 3 enter, and I'm just going to do it again, even though it's already a 2 by 3, just because it might be something different. Okay, so what are the numbers that I'm going to put in across that top row? 3, good. 2, -1, good. Okay, now 7, -6, 19. Good. Okay, do you know what to do next? Okay, so we hit second mode to come out, second matrix to go back in, and I'm going to go over to math. Now what do I go down to? Good, RREF. Okay, do you know how to get back to the matrix? Okay, well you call Neo or Morpheus or one of those guys, but we're going to hit second matrix, and we're going to hit A here. Okay, we hit enter. So our answers are 1 and -2 for X and Y. Okay? So you want to practice with that because it's going to make things a lot easier. All I need to see on your paper is the 2 by 3 matrix that you're making, the RREF, and the 2 by 3 matrix that it comes out to. Be able to show me which one is X, which one is Y, that type of thing. What's your question? If it doesn't tell you how to solve it, it really doesn't matter. But in all honesty, anytime it's a system of equations, I don't care. If you can find the correct answer, that's what I'm interested in. Okay. I would rather not on substitution because substitution's easy enough to do that you should be able to. On the inverse matrix, just because we don't mess with that often, and I showed you how to do RREF, use RREF. Okay? All right. Are there any other questions from the review that we have not covered? We've covered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We've covered about half of them. We're gonna review some more tomorrow. So any questions we haven't already covered, if anything that you want to cover, we can cover tomorrow. Okay? All right, we'll go ahead and stop it there.